It's a tough one. Okay, let's try this one. Square root of 3x plus 4 equals 1 plus the square root of 2x plus 2. Alrighty there. Okay, we have one of the radicals already alone, so we can go ahead and square both sides of the equation. Thankfully on this side we have the 3x plus 4 left. That side's the blessing, this side's the one that's going to make us work. We're going to FOIL. So we're going to do 1 plus the square root of 2x plus 2, 1 plus the square root of 2x plus 2 to FOIL that. So, and again, the reason we have to FOIL is there's two terms here. There's only one here. There's one whole set right there, but here we have a set plus some more. Okay, so if you like to use the word FOIL to do this, you're welcome to. I know there's other ways, so multiply those whichever way works well for you, but for me, I like FOIL. Alright, so I did the first in each set. Outer edges was 1 times that. Innermost was this times 1. And then ending with 2x, square root of 2x plus 2 times square root of 2x plus 2. And that's like squaring it like we did up here. So it just produces what was in the radical. So 2x plus 2 out of the radical. Alright, so we have a 2 and a 1 that come together that are like. And we have a plus 2x. And then these two come together. Remember, there's a 1 in front of them. So it's really a plus 2 with that common radical. All right, here we go. Sorry, I'm making that focus go out with my hand underneath here. Okay. So we did the first round. We squared both sides, FOILed this side, and this is what we have. Now we have to get this radical by itself. So we're going to go ahead and subtract 3 from both sides, and we'll subtract 2x from both sides. I don't usually do 2 steps at once, but I think you guys are pretty good. You can handle this. So this is going to be x plus 1 equals 2 times 2x plus 2. Alright, it's not ready yet. It still doesn't have the radical alone because that 2 is sitting outside of it. So we need to divide by 2 on everything. Okay. So we have x plus 1 over 2 equals the square root of 2x plus 2. That is not pretty, is it? All right, but the radical is alone on one side of the equal sign. So we can now square this. So we have 2x plus 2 on this side. This one's not any fun because ultimately you have to FOIL. It's x plus 1 times x plus 1. So we'll come over here a second and let's do that. X plus 1 FOILed is x squared plus 2x plus 1. So that's the top portion, and the bottom portion is 4, because 2 squared is 4. Okay, so now we have gotten rid of the radicals. That's great, but now we need to solve for x. And so we want to make this equal 0, and I think the easiest thing is to just get rid of this side. However, we got the fraction going on here. And you want to first get rid of the fraction. So we'll multiply the whole problem, both sides, by 4 to make this have no more fractions. So when you do this times 4 over 1, remember when you multiply fractions, you can reduce in opposite corners, so both of these can be divided by 4. So it doesn't change anything about this side. We're just left with the top only. And then this side, nothing canceled out because there wasn't fractions. So what we have now is x squared plus 2x plus 1. And we have 8x plus 8. And we want to make this equal 0 so that we can factor it, solve it. So let's subtract 8x from both sides, where we have like terms. And we'll also subtract 8 from both sides so that we can say this does equal 0. So now we have x squared minus 6x minus 7. Look at all that work we've been doing. Yes, it's crazy. I totally agree. Okay, let's factor this. X and x. So it's going to make 7. So we know it's going to be a 1 and a 7. And it's got to be a negative 7. So one of them is going to be positive, one negative. This always tells you what the largest one is. So that's how it's going to set. All right, so we set each one of them equal to 0 and solve. And so we're saying x is negative 1 and x is 7. So then we have to test it and find out. Let's try the negative 1 first. Let's go back to the original problem. Clear up here, negative 1 into this. So we'll say square root of 3 times negative 1 plus 4. Does that equal 1 plus square root of 2 times negative 1 plus 2? Well, let's see. 3 times negative 1 is negative 3. Negative 3 plus 4 is 1. So this side equals 1. Square root of 1 is 1. 2 times negative 1 is negative 2 plus 2. So that's the square root of 0. So 1 plus 0. So this is true. Negative 1 worked. Crazy but true. Let's try the, what was the other answer? 7. So we would have from our original problem, square root of 3 times 7 plus 4 equals 1 plus square root of 2 times 7 plus 2. Okay, I was trying to see the equation all at the same time. Got a messy paper here. Okay, so 21 plus 4 is 25. Square root of 25 on this side gives me 5. Here we have 1 plus 14 plus 2 is 16, right? Square root of 16, which is 4. So 1 plus 4 sure does equal 5. So both of these numbers are solutions.